Right, so this is a mini stream. This is just something to help a patron of mine. If he wants to be known, speak up now, and then I can refer to him. If you want to stay secret, I'll just refer to a patron. You released your... Oh, I'm going to have to... you'll have to send me the link, mate. So, Gary Meg, one of my patron, a new patron, or I should say not new patron, a return to the fold patron, is reverse engineering TRAXX, the VIC-20 game, to make it work on a 64. Cheers, Docster. And we reverse engineered it, way back. It must have been 2020. Must have been 2020, where we did a stream of reverse engineering the TRAXX system, but he's trying to take the TRAXX code and literally convert it into C64 code without having to change too much, and so he's struggling with the joystick routine, and I understand why he's struggling, because I've looked at the code, and yes, they've coded it. They've coded it and in a weird way. So we're going to go through it, and then we're going to try and see if we can replicate the same system but on the C64 joystick as well. So we'll get started, yeah? So I need to nick some code from the last stream. Let's see. Because I need the routine to show the contents of the register. Hang on, let me just see if I can find it. I'm sure I made it into a aha, there it is. There it is. Let's grab that. Just put it in here. Now this is in CBM format. Just do a quick conversion. Right, I need temp. We need a temp variable. There it is. We'll grab that. Right, let's put that there. Right. And we need to change that because I think it's 1E. 1E for the VIC-20. So, what we're going to do is we're going to ram that out. And we're going to get it to jump to start. So I've got the joystick routine that Gary... Can you see that, by the way? Let me boost it. There we go. Can you see it now? Got one more. There you go. Super large. I could take my glasses off for this. Right. So I assumed that this variable here was 9111. Yeah? Is that right, Gary? Is that what you've got? So VIA PA2 is 9111, yeah? I assume. Yeah. Right. So what we're going to do is, because I'm keeping the original code, so a store A, so we're going to JSR our print binary routine. Find out binary routine. Just to find out exactly what's in the accumulator. Yeah. So this should print out what we're storing in 08. So I've pre-configured this, so this should work. I made it into a workspace, so it should work. Ow. There we go. So at the top, we've got our register for... Oh, sorry to say, we've got the output from that routine being stored at the top of the screen. So if I press any key, press the joystick keys. There we go. So that's up. That's up. Down. Left. Right. Fire. Yeah, so this is what I understood the outcome to be. So that's just confirmed it. So we'll go and try and explain exactly what's going on. So here we're setting up a mask, which is that. And basically that's telling the CIA, that's telling the sorry, not the CIA, the VIA, and I think 922 is, because I've got the trusted VIC-20 programmer's reference guide here. Dug it out. So 9122 is port B of 2. 9122. So what we're doing, we're telling port B of the VIA chip that we want that bit to be an input and the rest of it is still an output. Yeah, so we're changing bit 7 to be an input, and then what we're doing here is we're reading then 9120, which is actually the register. So this says output register, but because bit 7 is an input, so it's classed as an input register. So we're reading that input register. Yeah, we'll get there. So it's reading that, and then what it's doing, it's saying if it's not equal to 0, yeah, that means if it's got any value, it loops back round. Loops back round. And the reason for that is, like I said back when I was doing the joystick part of Hunchback, the input output is always 1. If it's not pressed, if you've not pressed the switch, it's always 1. As soon as you press the switch, it becomes 0. Yeah. So because we've told it that we want to listen to bit 7, sorry. If it has a value, so bit 7 will be $80, let's for example. If it has a value, it's saying nothing's been pressed, so it loops back round. So if it's 0, hey ho, bingo, we carry on. Then we're changing 9122, we're resetting it back, and then we are changing 9120. And the reason for that is because now we're listening to the second output, which is this one. Because the first output is got joystick switch 3. Now joystick switch 3 is right, I think. Yeah, right. So it's right. And so the other port will have up, down, left, right and fire. And that's what they're doing. So we've set up the other one, so F7. We read it, same philosophy. If it's got a value, we just loop round. If it hasn't got a value, blah blah blah, we carry on. Once we've got it, once we have some sort of result, we push it to the accumulator, and then we AND it with 1C. So that would be that. Yes, we AND it with that. And the reason why we're ANDing it with this is because that there is up, that there is down, that there is left. Yes, left. So we end up with a result that looks like this. So that is left, up, no, down, and then up. Yeah? So we've just masked off the rest of that port, and we're just interested in the 3 that we want, which is up, down, and left. Then we shift it. So then they're shifting it down. So it'll end up looking like this. Yeah? So then they shift it down. Then we compare with what we picked up here, because we loaded Y with the other register. We compare to see if it's 80. Right? Now, what they've done is, if it's less than 80, we bypass it. If it's more than 80, then we OR the accumulator with 10. So it ends up looking like this. 1, 2, 3. So then we end up with a profile, a joystick profile that looks like this. So that's right, left, down, and up. Yeah? And that's what we end up with. So what they're doing is they're taking the joystick from two ports and trying to combine it into 1 byte. But that's all well and good. So we've got left, right, up and down, but then we need fire. And so what they're doing here is, once they bypass it, they load what we got back out of the port, and then we AND it with this. That's 20, isn't it? Yep, that's 20. Then we test to see if it is 20. So what's that bit? In fact, that's not 20, is it? Yeah, it is. Yeah, it is. Yeah. Yeah. Then we compare it with 20. Yeah. So we're testing to see if the fire bit has been pressed. If it has, we transfer our resulting joystick byte back from the Y register. We rotate it, so they rotate it like this. Oh, hang on. So we end up, so we've got, let me just do it on the line before. So our result potentially could be this. And then they're rotating it right. So they're rolling it. So they're taking the end. So they're taking this end bit here and putting it there and shifting everything over. So it ends up looking like that. Yep. If and the reason doing the rotate, because of the compare. Yeah? Because if it's less than, remember, if it's less than, the carry bit equals 0. But if it's greater than or equal, whoa, 2, then it equals 1. And this is why they are rotating it, because what's happening is they're taking the carry flag and rolling it in. So at the end of here, we could have a carry flag of 0 or 1. So if it's 1, which is what we're hoping for, then we end up with a profile like that, if it's been fired. But if there's no fire button, hang on a second. Remember, I'm Minecrafting at the same time. Right, so if there's no fire button, then we will end up with a result that looks like this. Yeah. But if there is a fire button, then we end up with that. Yeah. Now you've got to remember that this is the opposite way round. So in reality, we are like this. In reality, that's what we're like. Yeah. Because remember, the VIA and the CIA chip is the reverse. 1 means we haven't pressed, 0 means we have. And that's where this XOR comes in. Because what that's doing, XOR is doing our reality, so it's doing this. 0, 1, 1, 1. 0, 0, 0. XOR with 1, 0, 0, 0, 1, 1, 1, which will equal, if in an ideal world, that situation would equal 1, 0, 0, 0, 1, 1, 1, 1. Yeah? And you know what an XOR is? If they are both the same, it's a 1. If they are both different, it's a 0. Or is it the other way around? No, if they're both the same, it's a 0. If they're both different, it's a 1. Oh dear. Yeah. Yeah, if they're both different, it's a 1. Both the same, it's a 0. Oh, it's New Year's Day. Can't have this. Right. So you end up with no. Oh, my brain's gone to mush. You what? Too much Minecraft. Yeah, I'm right. Both the same 0, but if they're different, the ones. Yeah, I'm right. I got there in the end. And so what that's doing, it's converting all it's converting, if it's a 1 into a 0, yeah, which are the bits that we're not interested in, and all the bits that we are interested in become 1s if they are 0s. Yeah. And so we end up with a profile of this. So we end up with a profile of this. So that's fire. Oh. Right, left, down, up. Right, left, down, up. And that is how the resulting VIC-20... well, that's how Mr. Minter has interrogated the joystick, and that's the resulting joystick profile of that byte that then we store in OA. And we've proved that because we ran it, and across the top we had what was the thing, what was the result. Now, to convert this into a C64, to convert this routine to C64 is going to be really easy, because the C64, the joystick 2 is on one port. The difference is the bits are in the different order, and so we have to then have to remap those bits onto the C64. What's wrong, Stacy? So, what we need to do is then we need to Yeah, sure, mate. I'll put this in Discord, mate. I'll put the project in Discord. So what we're going to do is we're going to so this is the VIC-20 workspace. We're going to create a C64 workspace, and we're going to try and replicate this for the 64. So let's create.
John here. Thank you for following. Hope you enjoy the stream.
Hey! Now my bot still can't handle new follows. So, there you go, mate. It's updated. Thank you for following, mate. Thank you for following. Right, so we are going to create a new workspace, which is this one here. So rename, and we're going to call this C64. And we are going to change the X64SC, I think it is. We're going to get rid of that because we don't need that. Right, save that. And what we're going to do is we are going to create another one. So we'll copy that. And we'll do that. Right, so what we're going to do is we're going to load the workspace. Going to load the workspace for this. So file, open workspace file. So this now should be in C64 mode. So we'll change that to make C64 Joy. Oh, come on, leave me alone. Right, so that should be in kick. It is. Right, so our start position for the C64 is 08. And we're going to try and replicate this function but in the C64. So I'm going to cheat because I have got Pesky Matrix open here. Because we've done it all before. Right, Pesky Matrix, joystick routine. Where are we? There we go. There it is. Right. This is the joystick routine for the C64. Right. So, let me load the C64 book up. Where's the books? Let's go to the programmer's reference guide. It's so much easier. Well, it is on port 2. Port 1 is a bit more trickier. But we're only going to be doing port 2. Right, I'm just trying to find the C64 book. Hang on. Ebooks. C64. Programmer's reference guide. Where are we? Oh, where? Oh, there it is. Here we go. Programmer's reference guide. Right, let's see if we can find the joystick section in here. So we can look. Because I've forgotten what bit is what. There are some madmen out there that do it. Joystick. Is it not in here? Oh, is it right at the very bottom? C419. You'd think they'd have a section on joystick, wouldn't there? Graphics, standard, extended, multi-sprites, other, program sprites, SID, machine code, input output. Gotta be in there. Paddles. Yeah, okay. Light pen. Okay. User port. What? There's no joystick section. Really? Wow. Okay, right, we'll go to 419. We'll go to 419. Here we go. 849. Yeah. Yeah. Right. Does it go into detail for the joystick? No, it don't. Right. Okay. Let's go to the trusted one. Yeah, I'm just going to find it now. Here we go. Right. It's the first one, I believe. There we go. Right. So, bit 0 is up. Up. Bit 1 is down. Bit 2 is left. Bit 3 is right. So that obviously is fire. Right. So there's our profile we have of the C64, and it is very similar to their end profile. Right, left, down, up. Right, left, down, up. So we're all right. So the only thing that we need to do is move the fire bit. So we can do this. Let's see. Right, let's see if we can do this by an XOR. So we need to XOR. We need to XOR this. So we need to convert this. We need to convert this into that. Yeah. So, can we do that by an XOR? Let's try it out. Let's try it out. So, we've got two states. That is no fire, and this is fire. So if we XOR with, let's see. No, that's not going to work, is it? Because we're expecting it to be the same. Right. So what we need to do is we need to so we'll store this away. We'll store that away. So we need to AND with we need to AND it with that. Branch if equal to 0. So if the fire button's not pressed, it will be 0. If the fire button's pressed, it will be not 0. Oh, 3, 4, 5. Oh, so it is. Well done, Gary. So it is. I thought it would have been strange of not putting it in there. Right. So, because it's not 0, that means we've pressed it. Right, and the reason why I say because it's not 0, because we've already done the invert there. Yeah, we've already done the invert there. Oh, I need to put that in, don't I? That's DC00. Right. So let's put the bypass here. So if the fire button is pressed, yeah, the fire button is pressed. If it's not pressed, we don't do anything, but if it is pressed, we need to do an XOR. So LDA temp XOR, and we are going to do is that going to work? No, that's not going to work. So we're going to do it the two-stage way. So we're ANDing it. So we're going to mask everything off, keep everything bar that bit, and then OR it. So here we're turning off, turn off fire bit, and here move fire bit to bit 7. And then we'll store it back into temp. Yeah, sounds a lot easier on the Vic sounds, but you should be able to get it. We should be able to get the basic sounds on the C64 up and running. You know, pick a waveform, sawtooth or triangle. I think the numbers are very similar, but that's something else. Right, so we bypass it. So what we're going to do is we're going to do the same thing as we've done down here. We're going to grab that and we're going to put it there. But this one is now 400. And we can get rid of all this. Because this is now for the C64. So we should now, if we run this, we should now have the C64 version of the TRAXX mapping. Let's try it. Let's see if I broke it. There we go. So we've got our bit profile at the top of the screen. So here we go. Up. 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 Oh. Boom. What have I done wrong? Oh, I see what I've done wrong. I see what I've done wrong. Right, up, down, left, right, fire. There you go. So there we are. We have now converted the C64 joystick profile into the TRAXX joystick profile. Yeah, the RTS is just if you wanted to jump straight back out, but we're looping through it, yeah. So we're not ending, yeah. So the RTS would be in place, you know. This would be your routine, yeah, and you would put the RTS, you would activate the RTS and take out the start, yeah. That's why I left the routine name in there for you in the TRAXX. So there you go. That's how you would convert the VIC-20. So let's do this. So this is the VIC-20 routine. And this is the C64 routine that gives you the TRAXX joystick profile. And that's how you would convert the C64 joystick profile. Was referring to sounds. Yeah. Now this RTS, you would activate this in your code. So when you replace this code in the VIC version with this code, just take out that. You don't need that. Well, you don't need that either, to be honest. All that. So this would be like this. There we go. That's the end result in there, isn't it? Yeah, OA. Alright. So, told you it was going to be a short stream. 50 minutes. Alright. So that's how I've converted it. I've got it written down here. That's how I converted it. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.